Hi students, in this video we're going to cover the segment addition postulate. Our objectives are to learn the segment addition postulate, learn congruence, and use the midpoint of a segment. All right, so the segment addition postulate is similar to the angle addition postulate. If we have an entire segment and it's broken into smaller parts, the sum of the smaller parts is equal to the entire segment. So for instance, say I tell you that the length of AB is, I will say this is 10, and we'll say this is 25. Then what we know is segment, so AB is equal to 10, and we know BC equals 25. We expect AC to equal 10 plus 25, and so that is 35. And that's the segment addition postulate. The sum of the smaller segments equals the entire segment. So for the first example, we're trying to find the length of AB, and so we know the entire segment is 13 and BC is 5. And we can just put in an X for the unknown. So we know X plus 5 equals 13. And so X is going to equal, we subtract 5. And so X is going to equal 13 minus 5, which is 8. And so I always recommend you substitute that value back in and see if it makes sense. 8 plus 5 is 13. So that's how we know it's correct. For example 2, our entire segment is 9, and we want to find the value of KL. So again, we'll put in an X. And so we're solving the equation 3 plus X equals 9. We subtract 3 from both sides, and we get X equals 6. So this segment is equal to 6. 3 plus 6 equals the entire segment. That's how we know it's correct. Oh, this is a duplicate, so we'll skip that one. So now we are using some algebra, but the concept is still the same. We know that MK is going to equal the length of ML plus the length of LK. And so we're going to have 11 plus 3x minus 2. Those are the two smaller segments. And that's going to equal 3 plus 5x. So when we combine like terms, 11 minus 2 is 9. So we get 9 plus 3x equals 3 plus 5x. So maybe we subtract 3x from both sides, and we get 9 equals 3 plus 2x. Then we subtract 3 from both sides, and so we get 6 equals 2x. Then we divide both sides by 2, so we get 3 equals x. And so from here, we need to find the length of MK. Since we have an expression for MK, we can just substitute 3 in directly. So we get 3 plus 5 times 3. That's going to equal 18. So that entire segment is 18. I encourage you to also substitute the 3 in for the smaller segment. So 3 times 3 minus 2, that equals 7. So 11 plus 7, that's 18. That's how we know our smaller segment also works. So then we have example 4. We're going to find the length of HJ again. So we know that HI plus IJ is going to equal HJ. So HJ is equal to HI plus JI. And so that means we get the equation 7 plus x plus 6 equals 3x plus 3. We combine like terms. We get 13 plus x equals 3x plus 3. We subtract 13 from both sides. We get x equals 2x minus 10. We subtract 2x from both sides. We get negative x equals negative 10. Then we divide both sides by negative 1. So we get x equals positive 10. So x equals positive 10. So if we substitute in 10, we're going to get 10 plus 6. This segment would be 16. So we get, we have to find ij and x. Did I make a mistake? So we would get 7 plus 6 is 13. Did I write that down correctly? 7 equals, so 7 plus x plus 6 equals 3x plus 3. And 13 plus x equals 3x plus 3. Subtract 3 from both sides. Oh, I'm sorry. This should have been a 3x. Let's go back a moment. My apologies for this mistake. Right here, this should be, so we subtract 13. That's going to give us x equals 3x minus 10. And so then we subtract 3x from both sides. And we get negative 2x equals negative 10. And we get x equal, we divide both sides by negative 2. And so we get x equals positive 5. So my mistake, I apologize. So if x equals 5, this segment is going to be 3 times 5 plus 3, which is 15 plus 3, which is 18. And if x is 5 up here, 5 plus 6 equals 11. So 7 plus 11 equals 18. So that's how we know our work is correct. So when we talk about congruent segments, congruent means same size and same shape. When we're talking about segments, congruent segments mean they are the same length. We're going to use this symbol for congruent. And later on, maybe in practice problems, you'll see the word bisect. Bisect means it divides a segment into congruent parts. And if we know that a point is the midpoint of a segment, it means that point bisects the segment, which means that the two smaller segments are congruent. To mark segments as congruent, you have to put the same number of tick marks on each segment to indicate they're congruent. So since AM and BM both have two segments, we know they are congruent. This statement, AM, segment AM, and this symbol is congruent to BM. So this means segment AM is equal to segment BM. That's what this statement means. It's read as AM is congruent to. So this symbol means is congruent to. That's what this statement means. This symbol means. It means is congruent to. All right. So the first thing we have is if G is the midpoint of FH, find FG. Remember on the previous slide we said the midpoint of a segment means the point bisects the segment. So G bisects this segment FH, which means that FG and GH are congruent. So what we know is FG is congruent to HG. And all that means is that FG, the value of FG equals the value of HG. Remember, the bar over the top means the segment. Without the bar means the length of the segment. So the length of FG equals the length of HG. So our equation is 11x minus 7 equals 3x plus 9. So then we can subtract 3x from both sides. So minus 3x. We get 8x minus 7 equals 9. And then we add 7 to both sides. So that's going to give us 8x equals 16. We divide both sides by 8. And so we get x equals 2. So to find the length of FG, we need to substitute in 2 for x. That's going to give us 11 times 2 minus 7, which is 22 minus 7. That's going to be 15. So if G is the midpoint, then GH should be the same, and we can check that. So 3 times 2 plus 9 is 6 plus 9. It's also 15. So since both of those segments are 15, we know our work is correct. So next we are told that ST is congruent to UT. So if ST is congruent to UT, we're going to mark that. So ST is congruent to UT. We put a single mark on both segments to indicate they're equal, and we need to find TU. So since they're congruent, it means that the length of ST, which is x plus 16, equals the length of UT, which is 2x plus 23. We can subtract x from both sides. We get 16 equals x plus 23. We subtract 23 from both sides, and we get negative 7 equals x. So that's a perfectly valid answer because x can be negative. Our segment length can't be negative. So if we substitute in negative 7, we get negative 7 plus 16. That's going to be a positive 9. If we substitute in negative 7 here, we're going to have 2 times negative 7 plus 23. 2 times negative 7, that's negative 14. And negative 14 plus 23, also positive 9. So both of those segments are 9. And since we had to find the value of TU, we know that TU equals 9. So in our last example, we have BC is congruent to BD. So we can put 3 ticks on this one, and that's just going to mean that those segments are congruent. So, and we need to find the length of BD. So first, since we already know CD is 8, and BC is congruent to CD, we know that BD actually just equals 16 because BC also equals 8. But if this actually had an expression, we just solve 2x minus 16 equals 8, and we add 16, so 2x equals 24. We divide by 2, so x equals 12. And if we substitute in 12, 2 times 12 is 24, minus 16 is going to be 8. And so BC is just going to be 8 plus, BD is going to be 8 plus 8, and that gives us 16. All right, so that concludes our lesson for segment addition. The new concept that we picked up is segment addition is if a segment is broken into smaller segments, you can add the 2 smaller segments together to get the value of the larger segment. And we also covered congruence, and congruence means same shape, same size. It also means that the segment values are equal if segments are congruent.